Hi everyone, so today I'm going to speak about factorizing expressions, which is actually opposite to multiplying or expanding brackets. So I'm actually going to make a little bit of a comment over here. It's opposite. Maybe opposite is not the right word. It's the other way around of expand brackets. And I find it obviously very interesting. And also sometimes it's a bit harder to spot some of the things. So I don't think is straightforward. So I'm gonna start with a couple of easy examples that speak about common factor. So the first one I have is 2x plus 4. And the way I want to present this is we need to look at these two things. So we have two terms, the 2x and the 4. First thing, I do recommend to look at the numbers. So you can be like, I look at the 2 and the 4. Is there anything common with 2 and 4? And hopefully the first thing that will come to your mind is they're both in the 2 times table. And that's exactly what we need to figure out. Because the common thing of 2 and 4 is that they're in the 2 times table. So I put the 2 in front of my bracket. And then I need to look at what I have left. Now, when we say what I have left is I look at the first term. I've put the 2 in front of the bracket. Now I'm left with the little x. So the little x has to go inside the bracket. And then I look at the other one. I've got 4, but I took the 2 out. So I kind of need to think of like 4 divided by 2 to give me the 2 that I put in the bracket. And because I'm speaking about positive 4 that I divide by positive 2, I should get the plus there. So that's kind of the basic thing. So the 2 is the common factor. And this 2 over there comes from this calculation on the side that, again, it goes pretty straightforward. So now if you want to check this, we've done this before where we actually, so I'm going to put it here, where we check that we've got the right answer. So we've got 2 bracket x plus 2. So as you remember from multiplying or expanding brackets I've done a couple of weeks ago, I will put it in the corner up there just as a reminder. We do 2 times x and 2 times 2. So 2 times x, that's 2x. 2 times 2, that is 4. So we got what we started with, which is exactly what we want. Now I'm going to go through a couple of more examples like this. But without doing the check for the next one. So I've got a 3p minus 12. So again, following on the same idea, I've got the 3 and the 12. I've got a negative 12 now, so I need to be a bit more careful. They're both in the 3 times table. So 3 is my common factor. And then I look at what I have left. So I'm left with p from there. And this one is negative 12 divided by 3. So that gives me negative 4. And that's it. So if I multiply 3 by p, it gives me 3p. If I multiply 3 by negative 4, it gives me negative 12. So I'm there. I'm getting there. Now, if I don't have numbers like that, but I do have letters. So let's say I have AB minus BC. Now this time I don't have numbers, and I do think this is a bit more easier to spot because you're looking at an A and a B and a C multiplied together. So hopefully it's quite obvious that the bit that's in common is just B. I don't even need to think about my times table or anything. It's on the page. B is the thing that's on both terms. So B is the bit that goes in front of the bracket. Then I look at what I have left. So if I don't have the B there, then I'm left with an A and a C. So A and a C, and I need to be careful the sign is negative. So I think personally that the ones that have just letters are a bit more easier to spot which one is the actual common factor. So, which is on the same in the terms, and it's actually a factor of each term. So, but if they're like that, I think they're easy. But if they look like this, so let's say I have 4x squared plus 8x. Now, this already for me has a couple of issues. First, I have numbers on both and I have letters on both. So that's my first issue. I need to be careful because I have letters and numbers. And the second one, I need to be careful what happens with this x squared, and I need to fully understand that the x squared is actually x times x. So I do have x here and x there. So I need to be very careful. The way I look at this one, to be fair, is I look at numbers first thing. So I look at the 4 and the 8. And they're both in the 4 times table. So I put the 4 out of my bracket. Now, before I go on straight away and think like, oh, this is the only thing, I look at the letters next. So I have x squared here and an x there. So it's obvious that both of them have x in common. So I've put the 4x as the common thing. Now, I can open the bracket because I've looked at both the number and the letter. And I need to be very careful. If I look at the number here, I already have it outside, so I don't need to do any calculations with it. But if I look at the letter, this is an x squared, and I've put just an x outside. So that means in this x squared, there's still another x left. So I need to put that x in my bracket. Just because this is an x squared, so it's 2 x's multiplied together. So I've done the first term. I'm looking at the second term. I've got the 8 and I've got a 4 here. So 8 divided by 4, that's a 2. And then I've got an x here, but I've took the x outside the bracket, so I don't need to put anything. Here I'm speaking about positive 8 that I'm dividing by positive 4, so it should be a positive 2. And this is what I have. Now, it will get more confusing if I have more powers here. But if I pay very close attention to what I have in common, then it should be fine. So my common factor is 4x. I still want to do another example with this one. So I'm going to go with 0 for 4x squared. But I think I will, let's take away the 3x. Oh, sorry, it's supposed to be an x. Now, I look at the 4 and the 3. Out of the top of my head, they're not in the same times table. So I don't need to complicate my life doing like fractions or anything like that. So I'm just going to go with 4 and 3. They're not in the same times table. And I've got this is an x squared and this is an x. So the common bit is x. And I haven't done anything with 4, so it goes there. I have an x squared there, but just one x outside. So that means another x in there. I don't have any numbers, so I need to put the -3 there. And this is an x. I've already took the x out, so that's it done. So I think that slowly we can get there. Now I do want to mention something else here. I did mention this when I've done multiplying brackets, and I will put a video in the comment below and up here, because this is one of the formulas that I've discussed there that I think it's very important. So I'm gonna actually put the name of it. So it's difference of 2 squares. Now, if you remember the formula, that'd be really cool. So the formula that we actually found out then when we multiplied the bracket was that if we have a minus b bracket a plus b, when I multiply the bracket, this gives me a squared minus b squared. And I think it's really fascinating. But because we're factorizing, that means if I have a difference of two squares, I can automatically put them in two brackets. And I think it's fascinating how just knowing one pattern, like it just transforms this a bit and it makes it a bit hopefully easier. So the only issue here is for you to actually know all the square numbers. So I will explain when I get to the first example. So let's go with, I'm in the mood for x squared, so all of them are going to have x squared minus 9. And that's what I mean. If you see a 9, you need to be able to say this is actually 3 squared, to be like, oh, this is x squared minus 3 squared. So I actually have this situation that's on the top. So that's the issue. So now I have my a is actually x, the b is 3. So I go x minus 3, x plus 3. And it's pretty straightforward when you see it. And I think it's really cool that finding a pattern when we multiply the brackets actually helps me factorize this pretty straight away. So I think it's really cool. But it could get a bit more complex. So for example, if I have 5 x squared minus 125. So this one is not straight away a difference of two squares. It does have the x squared there, and it might look like this 125 could be a squared number, but it's not. The issue with this one is that I actually have a 5 in here, so I can take the 5 out because it is common to 125. It's a factor of 125, so it is a common factor. I'm left with x squared from the first one minus, now 125 divided by 5, that's 25. And now if I look at it like that, inside of my lovely bracket over here, I have a difference of two squares because this is x squared minus 5 squared. And now, knowing the pattern there and the formula, I can actually use it to simplify this. So this gives me 5x minus 5, x plus 5. So I think it's really cool coming from this to get this quite, not straight away, but like pretty straightforward. So I'm gonna go with the steps on the side here for the second one, because the first thing I've done common factor. And then I've actually found out the square number. So I managed to write everything like something squared and something else squared. And then the third bit, I've actually used the formula. So this last example kind of has the common factor I've discussed at the top and the lovely formula for difference of two squares. So yeah, I think I will leave this video here. I still want to speak about more factorizing, but I think I will leave it as a completely different video that I will speak about and film soon. So yeah, let me know if you enjoyed this. If you have any other method or like way of explaining this, I would love to see it. I think there are some really nice, like maybe geometrical ways of explaining this, but I've never actually tried any. So if you have any like that, please let me know in the comments down below, and I will speak to you soon. Have a lovely day. Bye.